All right, it's time for this week's question show. And we've got a special guest, which I probably put into the title, and so it's not going to really be a surprise. But Andy Weir is going to be answering a question for you, the author of The Martian and his new book, Artemis. So stick around. That's at the end. Or just skip and just miss all the questions in between. I don't know. You be you. All right, so before I get into this week's questions, I've been talking to a bunch of the patrons. Just, I like to interview the patrons and talk to them and sort of get their experience. And the theme that I keep hearing is that nobody has any idea about Astronomy Cast, this other thing that I've been doing, this podcast I've been doing for 10 years with Dr. Pamela Gay. We've got 460 episodes. So if you like podcasts, check out Astronomy Cast. You will have hundreds and hundreds of episodes of astronomy-related information to listen. It's where I'm talking to a PhD astronomer just about astronomy week after week for years and years and years. And that's really how we got started into this space exploring, explaining business. So check out Astronomy Cast. All right, on to the questions. Mysterious Nepal. You idiot made this video as exactly the article I have read. Question mark, exclamation point. So like I've seen this kind of comment a couple of times, which is like, this video is like word for word an article that I just read on the internet. Yeah, it's because I wrote the article and the video at the same time. So what I do is when I write a script for one of my articles, I put the article on my website, Universe Today, and then it gets picked up across a bunch of other places. I'll also embed the video inside of it. And so you'll see the article over on phys.org, and sometimes you'll see it on Futurism, and a bunch of other websites out there. And that's totally fine with me. And if you go and on my Contact Us page on the Universe Today website, and you're like, what are the rules for being able to reuse the material? There are no rules. Go ahead, use any article that you want that I've done, use any video, mix it, add it to whatever you're doing, be my guest. Send it out to your astronomy club, put it on your website, add it to a book, provide me accreditation if you can, that would be nice. But apart from that, I want this information to get out there. I want people to be able to feel comfortable using space information on their own websites, and that's just sort of part of the explaining process of my job. Now, to Mysterious Paul's credit, I responded to them in the comments, and they came back and were quite nice, which is funny to me that people will sort of have this initial comment and they seem very kind of I don't know, maybe it's a cultural thing, and but often people will seem very brusque when they first make a comment, and then I will respond, and they're like, "Oh, I love the videos that you do, man." I'm like, "What? Okay, I thought we were having a fight, but okay." Anyway, so yeah, go ahead, use our content for anything you want. You have my permission. Mycll DD. What does it mean for a black hole to spin? How can it have a speed when the singularity has zero radius? All of its mass is concentrated into zero volume, right? You can't know much about a black hole, but you can know a couple of things. You can know its mass, and the way you can calculate the mass of a black hole is by measuring how things are orbiting around it. And there's a mathematical formula for gravity that includes two objects, and if you know those two objects and how long they take to go around each other, you can get at the mass of those objects, which is really amazing. And so that's how astronomers find out the mass, is they calculate orbits, and that tells them the mass. To find out the rotation, what astronomers do is you've got this accretion disk that's around the black hole, and the faster the black hole is spinning, it changes the gap between the event horizon of the black hole and the accretion disk that is around it. The bigger the gap, the faster the black hole is rotating. And in theory, if you could come and actually look at the black hole and see the event horizon, you would see the event horizon flattening down as the black hole spins faster and faster. And black holes are limited by relativity. They cannot spin faster than the speed of light. They can spin to a significant portion of the speed of light, but as they get closer and closer, they're prevented. And this prevents the black hole from revealing itself. And this is one of these things that's known as a naked singularity, which you can't have because the relativity stops the black hole from being able to, the singularity from being revealed. And unfortunately, they will always be mysterious and hidden, and we can't tell. But that's how astronomers figure out the rotation rate of black holes. RockawayCCW. Just curious, what is the maximum speed that a spacecraft could achieve by slingshotting around the planets in our solar system? Man, Lagrange points and gravitational slingshots. You guys love these topics. Just the quick version of this, right, is that when a spacecraft, what a gravitational slingshot does is it uses the orbital velocity, the orbital momentum of a planet as it's going around the sun in orbit. So essentially, you let your spacecraft drift up to Jupiter, and as it does, Jupiter pulls it up into its orbital velocity, and the Earth is going 30 kilometers per second around the sun. Jupiter's going a different speed, slower, but it's farther out. And so you can essentially steal a little bit of this orbital velocity from Jupiter as you do a gravitational slingshot of it. The maximum speed that you can get is the speed that the planet is going around the sun. So once you are going the same speed as the planet, you're not going to steal any of its orbital velocity, and it's not going to give anything to you. And in fact, if you go faster than that speed, if you pass Jupiter and you're going faster than Jupiter is going around the sun, you're going to give it orbital velocity. So you're actually going to speed Jupiter up a tiny little bit as it's going around the sun. And so that is the limit. If you're going slower than the object is in the speed that it's going around the sun, then you will be sped up to it and you're going to slow it down, and the reverse happens as well. And so you can actually, that is the limit. Great video, Fraser. Is robbing orbital speed from a planet always done with the spacecraft coming from behind it? Could we slow down if we came in from the front? All right, another question about gravitational slingshots. So imagine you've got this spacecraft and it's coming in to Jupiter and gets really close, and you've probably even seen the animations, and it gets cranked around Jupiter. So one of the great things that you can use with a gravity well like that is you can use it to change the velocity that you're going. You change the direction and speed that you may be traveling in without having to use rocket fuel. So that's great. The other thing that you can do is that you can use gravity slingshots to slow you down, to use them to brake you. And so the way that works is that if you're coming in faster than the planet, then as you approach the planet, it's going to try to slow you down to its orbital velocity as it's going around the sun and pull you into that orbit. And so planetary rocket scientists can use these different planetary mechanics to make spacecraft do all kinds of things. It's like this gift that we've got here in the solar system, planets that are closer to the sun that we can use for certain purposes, and planets that are farther from the sun that we can use for other purposes, ones that are going faster and slower in different orbital directions. It's sort of like a wonderland of orbital slingshot opportunities out there. Chad Baptiste. Oh man, just thought of a dope question. Hopefully it makes it into your next QA. What resolution of detail would the Hubble Telescope be able to pick up were it pointed at Earth? Is it like Google Map detail or CSI's Zoom and Enhance detail? Hubble isn't pointed to Earth and kind of can't be pointed at Earth. But if it was pointed at Earth, you would be able to see objects as good as some of the best reconnaissance satellites that are out there. I think you could see about 30 centimeter sized objects, so the size of a person from space, which is pretty great. And one of the things that's really amazing is the National Reconnaissance Office recently, just about 5-6 years ago, gifted NASA two space telescopes that are Hubble class. And it was just like a surprise present. Like, oh, here's a couple of telescopes that are not good enough for what we need them to do, so why don't you see if you can use them for space science? And now one of these is going to be turning into the W1 mission, which we mentioned in the video. But it's kind of, so when you think about the capabilities of the National Reconnaissance Office, they clearly have ground-pointed telescopes that are capable of resolving details that are kind of mind-bending. I would love to know the details of those telescopes, but we don't, because it's a secret. John Farah. Hey Fraser, I am awesome inspired by Q&As, and I have a Q that I would love you and your community's thoughts on. As the only known observers, what are we? Are we bags of meat, bags of stardust, body with a brain with a body, a spirit in a vessel, a single organism, or a sentient community of organisms? I'm trying to keep my question short, but I guess I'm asking, what are we And what is the meaning of life, please? I don't know. This is one of those questions that is potentially impossible to know. All we can do is seek our curiosity. All we can do is try to uncover the answers, to figure out what it is, what we are, what we're made of, where we came from, where we're going, what does the future hold, what happened in the past, what is consciousness, why do we sleep, and a lot of these questions are being figured out bit by bit by bit. I think the thing that's most important about all of those questions that you asked is to not presuppose the answer. In other words, if you sit down for coffee with a bunch of your friends and you're like, why are we here? And then people give you the answers, they're just guessing, right? They're just making things up, or they don't know, because those questions are in many cases totally unknowable. And so I think it's really important, as we ask some of those fundamental questions, it's more about the framework that we use to try and figure out the questions to those answers. What is the method that we use to explore the universe around us? We want to use observation, we want to use data, we want to use evidence, and we want to use the scientific method to try and accumulate data to try and be able to make some answers. Because those answers, right? Why is there, why do things fall down, and what causes rainbows, and what causes the tides, things like that. These are questions that human beings didn't know the answers to for a long time, and then we figured it out bit by bit by bit. And that, I think, is so I guess my answer is, like, I have no idea to many of those questions. I'd love to know the answers, and let's find out. Grimbot 2. If the moon could be safely placed on Earth's surface, what would happen? Would it roll across the surface as the Earth rotates, or would it sink through the Earth's crust? Please don't do this. This would be very, very bad. So the Earth has hydrostatic equilibrium, which means that sort of the gravity is pulling its mass into a sphere. And the moon has hydrostatic equilibrium, which means that the mutual gravity pulls it into a sphere, which is sort of like the most efficient shape. That's why you get when you blow a bubble, right? It turns into a sphere, because it's the most efficient shape to contain the volume of air in between and have the largest surface area. And that's what happens with the Earth and the moon and anything that's really bigger than, or about Pluto-sized. The moon would sort of turn into lava and would spread out across the surface of the Earth, and the Earth would turn into lava, and the two would form this bigger ball that consists of the mass of the Earth and the mass of the moon. I don't know how long it would take, but it would be a terrible, terrible day, or weeks, months, as this happens. So please don't do it. Paul Clifford. Head over to Patreon. It's mandatory in every YouTube video now, huh? You're seeing what I think is this revolution in the creation of content. And for me as a creator, being able to create this material and answer the questions directly of the fans and be able to sort of show up every day and make a career out of explaining space and astronomy is one of the most amazing things that's happened in I think in media in decades. That suddenly a person who is willing to put in the time and is willing to put in the energy and the effort can make a career out of it. And I think it's amazing. And the alternative is ads, right? So, obviously there's going to be an ad at the beginning of this episode, and there's ads on my website, but I can imagine this beautiful future where there are no ads. And that I can't wait until there's this time when creators can make a career out of doing this stuff for a group of fans that love this material, and we're well on our way. I mean, we've got 800 patrons, 800 people who are glad that I'm doing the thing that I'm doing, that I'm getting this material out into the world. I think that is just an amazing example of what is going to be possible in the future. And you're seeing a lot of big media companies go out of business. People are getting sold. Mashable just got sold. Time got sold to the Koch brothers. You're seeing newspapers go out of business. Other people are putting up paywalls, right? So you've got to subscribe to be able to get behind the paywall. We don't have a paywall. With a Patreon, right? We don't need to have a paywall. We are funded by the people that are glad that we're making this material. And so that the people who maybe aren't supporting the Patreon still get to enjoy and appreciate the content, while other people who maybe have more money can do it. I personally look at the amount that I used to spend on cable every month, and then I just spend that on Patreon contributions to a bunch of different creators. And that's sort of the way that I kind of pay it forward. So yes, you're going to see, especially with adpocalypses happening, you're absolutely going to see more people shifting to something like Patreon. Ivaca Pavic. Why do you always say pretty much every black hole? Does it mean that there are galaxies detected without supermassive black holes in the center? What holds those galaxies together then? Pretty much, right? Most of the galaxies out there in the universe have a supermassive black hole at the middle. The ones that don't are the ones that had some kind of gravitational interaction or a merger with another galaxy, and the black holes interacted with each other and someone got kicked out into deep space. So it probably used to have a black hole, and now that black hole is gone. What holds the galaxy together? Well, the black hole is not an anchor to the entire galaxy. The black hole is a tiny fraction of a percentage of the mass in that entire galaxy. The thing that really is holding the galaxy together is this sphere, this halo of dark matter that surrounds the galaxy and holds it together. And that's what's really holding the galaxy together. It's not the black holes. KHH 1960. When using the transit method to detect exoplanets, how do they determine the size and orbital distance of the planet just by the amount of lost luminosity? Right, so with the transit method is where you have a star, you've got a planet that passes in front of the star, and we can observe how the light dips coming from that star and use that to calculate the planet. So the way this works is that astronomers figure out the percentage of the light that is coming from the star when it has no planet in front of it. And then they calculate the amount of light coming from the star when it has no planet in front of it. And then they calculate the amount of light that dips when the planet passes in front of it. So then they can perform a calculation. Now, they need to know the original brightness of the star. And the way they do that is that they use this technique called spectroscopy to determine essentially what the star is made of and what temperature it is. And that tells you the mass of the star. These stars fall in this really great line depending on what their chemicals are and what their mass is and their brightness. And so it's relatively straightforward for an astronomer to calculate the brightness of the star. So now they know the brightness of the star, they know how much the brightness of the star dips, that tells them how much light is being blocked, and that helps them calculate the radius of the planet that's blocking the starlight. M.Otto. Wouldn't a water shield a few meters thick be cheaper? So we just did an episode about how you could surround a spacecraft with an artificial magnetic field as a way to block solar radiation and cosmic radiation, and sort of at this point it's not efficient and effective, and so you really makes more sense to surround yourself with stuff. Now, the best stuff that you could surround yourself with absolutely would be water. And because, I mean, water is great at blocking radiation. You don't need much, just tens of centimeters of water would do a great job of blocking radiation. But you can use water for drinking, for breathing, for rocket fuels, all these great things that water is useful for. The problem is, of course, water is super heavy. So you need to carry that water up from the surface of the Earth and take it up into space. You also are going to need to put in a lot of fuel if you want to move the water to change the direction that it's going. But then, of course, water can be its own fuel, and so you can use the water as a method of fuel by splitting up the hydrogen and the oxygen and then combining it together. That's a kind of rocket fuel. So I can imagine in the future, when we're living in space and we're moving comets and asteroids and things around, that may be something that people do, is they grab a comet, they mine it out, they use it as both a fuel source and protection, but that is so far down a ways from where we are today. So there you go. Joe the Pro, 36. Glad to hear it. Without moon landings, Mars is a pipe dream. The only question I have is if the moon is suitable as a staging base. What do you think, Fraser? Great question, but I'm going to let Andy Weir answer this one. Andy is, of course, the author of The Martian, and which the movie The Martian was based on. And he also has written a new book called Artemis, which is all about a base on the moon. And Andy did an absurd amount of research in what a sort of a future colony would look like on the moon, and thought he'd be the perfect person to ask this question to.
The moon would be a decent staging base for missions to the rest of the solar system, like especially if you wanted to go to Mars. The main thing is that the moon's gravity is so much less than Earth's. It's a lot easier to get material off of the surface of the moon than it is to get material off of the surface of Earth. The moon has an enormous amount of oxygen and aluminum in its minerals, and with fairly lightweight reactors, you would have enough energy to smelt them. Aluminum, powdered aluminum and oxygen makes an excellent monopropellant, and so that you could actually have a fuel production facility on the moon. And this isn't some kind of ghetto fuel. This is like aluminum and oxygen those are the primary ingredients in the space shuttle's solid rocket boosters. So this is a very serious fuel. And so as a staging area for creating fuel, the moon would be ideal for exploring the outer solar system, well, Mars and beyond.
All right, well, thanks, Andy, for answering that question. And of course, Andy joined us for the weekly Space Hangout, which is this other thing which I should be telling you about, which is that we do this weekly show about all the big space and astronomy news, and you can subscribe to it, and I'll link to Andy's interview in the show notes and in the playlist that I put at the end of this episode, so that you can go and watch our interview with Andy. I'll put a card here somewhere so you can check that out as well. All right, well, thanks everyone who asked all the questions this week. Really appreciate it. As always, wherever you are on my channel, if a question pops into your mind, just type it in. I will gather them all up and I will answer them here. See you next week. So we just did a video about surrounding a spacecraft. Sorry, someone's taking out their garbage.